So hello everybody, and thank you for being with us today. Welcome to the third webinar in the AMFEP and FEDIMA series on the safe handling of enzyme in the bakery supply chain. Most of you online today probably also followed our two previous webinars in October. If you missed them, no worries. You can find the recording on our website. So my name is Céline Benini, and I'm working as Regulatory Affairs Manager in the Secretariat of AMFEP, based in Brussels. I'm happy to introduce this webinar series on behalf of our two organizations, AMFEP and FEDIMA. This joint industry initiative aims at bringing together the insights, best practices, and tools from producers of enzymes, AMFEP, and the users of enzyme in ingredients for the baking industry, FEDIMA, in order to control dust exposure in the workplace. Our common goal is to help safeguard the health of workers. AMFEP and FEDIMA have been collaborating for years on education and improvement of the handling of raw materials and ingredients that contain enzymes. One of the main outcome of the industry guidelines on the safe handling of enzyme in the bakery supply chain, which were published in 2018. This webinar series is largely based on those guidelines. As you can see in the program, the webinar series is split into 4 sessions, each one addressing specific subject from the industry guidelines. We believe the webinars are relevant for a large target audience, including SHE managers, WHS managers or OHS managers, all plant operational staff, R&D employees in the bakery sector, program manager and teachers in bakery education centers, representative of occupational health and safety organization, artisan bakers, bakers union representatives. It is still possible to register for the 4th and last webinar through our respective websites. Please note that this webinar is being recorded and will be available on our website as a tool for continued education. Now, let me briefly introduce AMFEP and FEDIMA. AMFEP is the Association of Manufacturers and Formulators of Enzyme Products. It has been created in 1977. AMFEP has represented since then and promoted the interest of the enzyme industry, now equating to more than 90% of European enzyme markets and 80% of world enzyme markets. AMFEP members are producers of enzymes destined to the technical, the feed, and the food industry. And through its activities, AMFEP promotes the safe use of enzymes, their sustainability aspect, and their contribution to innovation. FEDIMA is the Federation of European Manufacturers and Suppliers of Ingredients to the bakery, confectionery, and patisserie industries. They currently have 12 members as national association in Europe. FEDIMA members produce a range of intermediate products to bakery and pastry professionals, hence they are a business-to-business sector. FEDIMA mission is to promote favorable environment for the sector, which in turn can support a sustainable and innovative bakery industry. As you can see in the blue box, occupational health and safety is one of FEDIMA's 4 key areas of activity. Others are informed consumer and customers, food safety, and bakery sector promotion. Our collective goal as AMFEP and FEDIMA is to work on the control of occupational enzyme exposure in the bakery sector. We do this by developing practical, user-friendly materials for bakery sector, which combine the expertise of both of our organizations. We have developed several materials which you see listed on the right side of the slide. These are available on the AMFEP and FEDIMA websites. We will elaborate on the material later in this webinar. Before we start, a few words of clarification. The information we will present in this webinar series is free of charge and is based on information that AMFEP and FEDIMA and our members believe to be reliable. It is intended for use by persons having technical skills and at their own discretion. Since conditions of use are outside our control, we make no warranties and assume no liability in connection with any use of this information. Nothing in this webinar series is to be taken as a license to operate under or a recommendation to infringe rules. Our material only address the control of occupational exposure among the workforce, not toward consumer, as this exposure is practically non-existent. Please note that in cases where some brands are included in this presentation, they are only provided as an example. There are other brands on the market that are available with the same technical functions, and that AMFEP and FEDIMA do not recommend any brands in particular. In today's webinar session, we will take a more practical look at some of the options for the control of enzyme exposure, which are suggested in the industry guidelines for flour millers and ingredients manufacturers. It will be presented by Sarah Hutton and by Martin van Ooft. After the presentation, there will be time for Q&A. You can submit your question through the chat function during the webinar. So please write your question directly to the user called Q&A that you can see in the participant list, so we can collect the questions. We will try to respond to as many as possible, but if we don't manage, we will provide answer in writing after the webinar. So without further ado, I'll give the floor to Sarah and Martin.
Good afternoon, everybody, and thank you for being with us today. Welcome to the third webinar in the AMFEP-FEDIMA series.
My name is Sarah Orton, and I work as Technical Manager for LaSalle UK and Ireland.
And my name is Martin van Ooft, working as Open Innovation Manager for AB Maui. Both of our companies are members of FEDIMA. In this session, we will take a more practical look at some of the options which are suggested in the guidance document for industrial bakeries, flour mills, ingredient manufacturers and improver houses to control exposure to enzymes, enzyme dust, of course, at the source. In the next 40 minutes or so, we will give some explanations and suggestions on how to limit exposure to enzymes, mainly via general dust control suggestions. The first suggestion is, of course, not to clap your hands to remove powder when they are covered in dust, in contrast to the photo shown, as this would clearly increase dust formation. It's preferable for you to just rinse your hands under water, and the same holds for the removal of dust from your clothes. In the interest of time, we would like to invite questions, as Celine already mentioned, only at the end of the session. So in order not to forget them, please ask your question in the chat box to the Q&A user. And just a remark before we go on, we have been focusing up till now on enzyme dust. But of course, I want to make clear that everything said in this webinar and also in the previous ones also hold for flour dust. Our objectives for today's webinar are to consider at every step of your processes where you can pay careful additional attention to controlling exposure to enzymes and practical methods to do this. We shall begin with the storage and handling of ingredients, through ingredient blending, dough preparation and dough mixing, and finally ending up with the management of waste materials. Even though we have said in the title of this webinar that it's also addressing flour mills, you will understand that flour mills are not concerned with large-scale bread making or dough making. However, the general principles for controlling dust and avoiding exposure still apply in milling processes, where enzymes may be added to flour as mill correctors. Millers also need to be aware of any risk involved with the management of waste streams and rework, so that any exposure to dust is minimized. Most importantly, we will be looking at the best ways to handle spillages, as these are key times where there is a high chance of additional enzyme exposure if such spillages are not handled properly. So, if you're all ready, let's take a look at the first step, which is the storage of products, bulk storage. It is important to use a specific area to store all products which contain enzymes. As example, mill correctors, bags of mixes, bags of bread improvers, or just bags of enzymes. It's always preferable if silos or other closed-loop systems can be used, but we understand this is not always practical or feasible. When bags are used, bags may be occasionally torn open during delivery, transport, or opened before they are used. This can cause unwanted dust in storage areas. The risk can be very much reduced or even avoided if all raw materials are stored properly and in a well-organized manner, as can be seen in the photo at the top of the slide. For example, in the photo top right, if the top bag on the left was open or broken, it's advisable to remove it from the storage area immediately and have the product used in the process room in the process as soon as possible. Bags should not be left with open tops in the storage area, as this increases the chance of spillage, which can lead to subsequent dust formation. Partly used bags should be carefully closed, sealed, and stored in such a way as to minimize this risk, and, if possible, they should be stored in a separate area. This avoids contaminating the outside of closed bags with any dust and makes the cleanup of any accidental spillage easier to deal with in a safe way. When we then talk about ingredient weighing and adding flour or other dry ingredients together can lead to dust formation, especially when large volumes are used, or when weighing is done quickly and from an elevated height. Flour and other dry powders should not be tipped directly from the bag into a weighing pan, as it is very difficult to easily control the speed of the flow of powders directly from a bag. Best practice is to use a scoop to transfer powders into the weighing pan. Ideally, enough scoops should be available so that the ingredients may be gently transferred from different bags into the weighing pan or mixing bowl. This will also help to prevent cross-contamination of ingredients between the bags. The figure on the bottom left shows the correct practice to minimize dust formation, whereas the bottom right picture shows dust formation caused by rushed or inattentive weighing practices. The best solution of all, of course, is to have your ingredients automatically metered into the blending plant or into mixing bowl via a closed system, as you can see in the pictures on the top of the slide. However, the same safety principles still apply if you have to tip powders into the delivery hoppers of such a system. Even when best practices are followed, the weighing and additional flour and other dry ingredients will always lead to some formation of dust. A ventilation system at the weighing station is recommended, as you can see on the top left. But if you do not have such a system of automated ingredient delivery or a weighing station, an efficient local air ventilation in the ingredient weighing area already can help to significantly reduce the exposure to flour and improver dust. This is seen on the top right of the slide. The weighing cabinet on the top left has a back wall air suction so that dust is effectively extracted away from the operator. If you use a local system, the best effect is achieved if the inlet of the local exhaust is positioned directly above or just behind the weighing pan. Ideally, it would be just behind the weighing pan. In such a way, again, that the air and dust are extracted away from the user. The top right photo shows a good practice of using a local exhaust ventilation system, although it would be preferably to have the exhaust at the back placed a little lower, rather more behind the bucket. Even when local exhaust systems are being used, it's a good idea for the operator to use some respiratory protection equipment. The pictures at the bottom right of the slide show some recommended RPE, and these will be described in more detail later on during this webinar. It is usual for industrial bakeries and ingredient blending companies to have their flour and or dry powders directly delivered into the mixing station via a silo system, which greatly decreases the risk of dust formation. But when such a system is not in place, the opening and unloading of flour and improver bags are critical steps, during which dust may be released into the environment, and therefore special care needs to be taken to prevent this from happening. It is strongly recommended that bags are opened at the end, where they are stitched or sealed, and that the components are gently emptied into the hopper or bin from which they will be dispensed. The height from which the bags are emptied should be as low as possible, preferably directly putting the bag onto the edge or into the hopper or bin. Making a slit in the bag at the opposite end of the opening allows a small influx of air, which helps the contents to slide out easily and cleanly, without the need to shake the bag to remove the last few grams. If it is necessary, any knocking or shaking of the bag in order to remove the last of the contents should be done as gently as possible. It's advisable that operators use respiratory equipment during this operation to minimize exposure to any dust that may arise. If ingredients are delivered by hand, they should be added slowly from the bag, as we have already described, or by using a scoop if the full bag is not required. Any additional dry ingredients should not be thrown abruptly or dropped into the weighing equipment or mixing bowl, but added as gently as possible to limit any dust formation. In this situation, it's also recommended that the local exhaust system is put in place above and behind the mixer when dry ingredients are added. An example of that is shown on the top left. In industrial bakeries, where ingredients are delivered directly into a mixing bowl via a silo, the mixing bowl lid should be closely fitting to prevent dust from billowing into the environment. And an example is shown on the top left. Once all the dry ingredients are added into the mixing bowl, water and other liquids should be added slowly to the dry blend, preferably along the edge of the bowl, as shown in the picture on the bottom left, by using a guiding hose. This will limit the formation of dust during this phase of mixing, and it will also limit the formation of aerosols, which could be inhaled by the operator. When it is not about dough mixing, but about formulation and blending, the situation is more or less the same. Upon loading dry ingredients, such as concentrated enzyme products, into a blender, again, several precautions will have to be taken. The first very important thing is to always use RPE when filling a blender. Flour will be normally loaded automatically, whereas all other ingredients usually are added manually into the blender in concentrated form from bags. Again, making a slit in the bag at the opposite end of the opening allows a small influx of air, which helps the contents to slide out easily and cleanly. And again, no need to shake the bag in that case. As previously mentioned, The height from which the bags are emptied should be as low as possible. If it is at all necessary, any knocking or shaking of the bag in order to remove the last of the contents should be done as gently as possible. The ingredients fall from a height into the blender, and this can create dust or will create dust. A local exhaust system just above the opening of the blender will help to reduce the risk of dust reaching the operator. And you can see that on the top left on the slide. Nevertheless, even if there is a local exhaust system, bags will have to be emptied slowly into the blender. The blender opening, of course, needs to be protected with a grid to prevent bags or sacks from falling in. So, thanks to this grid, the ingredients will fall from a certain height. So the slower it happens, the better it is. Finally, empty bags need to be collected, preferably in large-scale resealable plastic bags, as shown in the picture on the left, where the bags, the ingredient bags, the empty bags, are placed into the larger plastic bag through an opening just at the local exhaust point. Workers undertaking these tasks should wear RPE to increase the protection against dust inhalation. When moving empty bags from the weighing area, they should be gently rolled or carefully folded to prevent unnecessary dust formation that may be caused by abrupt movements. While rolling or folding, the opening of the bags should be directed towards a local exhaust ventilation point, if there is one, as can be seen on the picture on the left. Dust formation should be minimal if this operation is performed properly, in contrast to what can be seen in the photo on the right. As you will understand, it's very important that bags are not rolled or folded with the opening towards the operator, as this will significantly increase the risk of dust inhalation. The bag should also be collected in such a way that further handling is minimized, as mentioned earlier, in a large resealable plastic bag. So now we have all the ingredients safely weighed, and we will talk about dough mixing in a minute. But first, let's discuss the best way to minimize dust creation during unloading of an ingredients blender. Unloading of the contents of a blender into bags or boxes, or normally a bag in a box, is the part of the process with the highest risk of dust formation. This part of the operation will always have to be done using respiratory protection equipment. The outlet of the blender needs to be placed as low as possible into the bag or box, and the filling of the bag or box has to proceed slowly. When the desired weight of the bag has been reached, the outlet from the blender will have to be closed until the next box appears on the belt. It's strongly recommended to carry out this whole procedure using local exhaust ventilation, which can be placed closely above the box. This is possible by using a double-walled exhaust pipe, whereby the material is leaving the blender through the middle section of the outlet, and the air suction is through the outer part of the pipe. And then we will continue with dough preparation and give the word to Sarah.
Thank you, Martin. So meanwhile, back in the bakery, once all of the dry ingredients have been added into the mixing bowl, the water and other liquid ingredients should be added slowly to the dry blend, preferably along the edge of the bowl and by using a guiding hose, as we've mentioned before. This should limit the formation of dust during this early phase of mixing and will also limit the formation of aerosols, which may also be inhaled by the operator. When all of the ingredients are added to the mixing bowl, the mixing can begin. But the greatest concentration of dust is generated at the start of the mixing process. There are many types of mixing bowls available on the market, but those with solid covers are preferred, as these help to contain any dust and therefore limit the exposure to the operator. Where only a grid-type lid is fitted to the bowl, an extraction system should be installed with the local exhaust ventilation point placed directly above or just behind the mixing bowl, as shown on the slide in the photo on the right. Slow speed mixing at the start of the process also minimises dust formation. As soon as all the dry and wet ingredients are properly blended, the mixing speed can be increased to develop the dough. Unloading of the contents of a blender into bags or when moving empty bags from the weighing so dough preparation. Dusting flour is sometimes used to help prevent the dough from sticking to the bowl at the end of the mixing process and to ease the release of the dough for further processing. This is actually not advisable, as it may of course also cause dust clouds. A better solution, if it is compatible with the specific product and process, is to use oil. A small amount may be streamed or sprayed into the gap between the edge of the dough and the bowl itself to release the dough more easily and completely at the end of the mixing process. Once the dough has been removed from the mixing bowl, it's quite common for dusting flour to be used on an automatic line to prevent the dough from sticking to the equipment. Automatic flour dusters are usually used for this purpose, and if they're correctly set, these will drop the flour only where it is needed and in such a way that dust clouds will not form. Nevertheless, care should be taken by operatives who are replenishing the dusters. This is usually done with a scoop from a wheeled bin containing a supply of flour. These bins should be refilled using the precautions we've already described for the unloading of dry ingredients to minimize the formation of dust and so to reduce the risk of inhalation. Wherever possible, benches made from materials such as inox, stainless steel or polyethylene should be used. These types of materials tend to be less sticky for dough handling, so that there is much less need for dusting flour. Dusting flour is an obvious source of exposure for an operative, and the amount and method of its use should be limited and controlled as far as possible. High levels of dusting flour not only increase the risk of inhalation, but can also be unhygienic and can have a detrimental effect on the structure of the dough itself. Where dusting cannot be avoided and no other alternative options are available, low dust or dust-free flour should be used in minimal quantities for dusting purposes. This type of flour is commercially available, but you can easily make it yourself by mixing conventional flour with a small amount of oil. For example, a mixture of 2 kilograms of flour with only 15 milliliters of sunflower oil could potentially reduce inhalable dust levels in dusting flour by more than 50%. And I hope it goes without saying that this should be prepared on the mixer at a low speed and preferably with a cake beater, so that you don't cause dust clouds whilst you're preparing it. Ideally, dusting flour should be sprinkled rather than thrown to limit dust formation as far as possible. As a reference, we have included a link to a video that has been produced by the British Authority on Health and Safety at Work to help to explain this issue. The video very clearly shows how effective low dust dusting flour can be, and the live link will be available to you when you download this presentation from the website. When you are considering the health of your operators, the measures to prevent dust formation need to be thought through for each specific step of your own process. Ideally, the installation of a professional air ventilation system should be considered first, as this can protect the entire workforce. A local exhaust ventilation system immediately removes dust particles from the air and should ideally be placed close to the points where the highest levels of dust are usually generated, for example, at weighing and blending stations. The use of respiratory protective equipment, which covers the mouth, nose and chin, is strongly recommended in areas where there is still a high risk of exposure to dust, even after all other methods to limit dust have been implemented. When respiratory protection equipment is used during enzyme handling operations, the filter type specification must be at least P3, FFP3 or N100. Waste packaging materials, whether from normal use of ingredients as we've described earlier, or the reworking of bakery ingredients that contain enzymes, should be handled with extra care to prevent the exposure of the operator to dust or aerosols. The best practice is to remove and dispose of packaging as soon as it has been emptied to avoid any further handling. For bakery powders, empty paper bags or cartons should be placed into a large polythene sack, and the neck of this sack should be tied closed when it is full to prevent any further exposure to remaining dust. Alternatively, waste packaging materials may be placed into a ventilated compaction unit, which extrudes the compacted packs into a closed polythene liner. But please be aware that any operator in the vicinity of the compaction unit may be at risk from dust inhalation, so they should always use the appropriate respiratory protection equipment, as we've already described in the previous slides. Where liquid products are concerned, empty containers pose little exposure risk unless they contain sufficient traces of the product to generate a spillage, or if they are shredded or compressed. The shredding or compaction of empty containers should be avoided if possible. This is because the necessary forces involved are usually sufficient to generate aerosols, which, like dust, can also be easily inhaled. Any spillage of liquid from empty containers onto the ground or hard surfaces can be avoided by making sure that they are completely drained. Liquid spills should be cleaned up immediately because dust formation can easily occur if any dried up residue is disturbed. The best methods for cleaning spillages will be discussed in the next slide. Please remember it's important that any third-party waste recycling companies should also be informed of the risks associated with handling these empty packaging materials. This is so that they can also take the appropriate steps to avoid any exposure to dust for their own employees. Cleaning up operations can be a significant source of peak enzyme exposures within the entire bakery chain, and these need to be carefully managed by a combination of the right equipment and procedures. The use of improper or improvised cleanup methods may actually generate airborne dust, enzyme dust or aerosols, risking the exposure of operators in the immediate area or even in adjacent areas via general air circulation. Cleaning up spilled bakery powder products should be done using a vacuum cleaning system that has been fitted with appropriate HEPA filtration. The air inflow at the vacuum tool provides some containment of dusts or aerosols at the pickup point. Industrial vacuum cleaning systems without HEPA filtration should be avoided, as standard filtration systems are not adequate to remove enzyme dust or aerosols before the air is returned to the working environment. This would ultimately result in more fine dust formation in the air, significantly increasing the risk of exposure. A further important consideration is the way in which the vacuum cleaner is emptied. The contents must not be disposed of in such a way that generates additional dust clouds. When spillages and contaminated equipment are being cleaned up, brushes, brooms, compressed air, and high-pressure water jets should be avoided, as these will generate either significant airborne dust or aerosols. Indeed, high-pressure water hoses may leave behind a residue which can then dry out to form an even finer dust. Vacuuming with a HEPA-fitted vacuum cleaner, followed by wet mopping, is the preferred cleaning method. Smaller spillages may be washed to a drain by using a soft or low-pressure water hose, but definitely not high-pressure hoses. Remember that using compressed air for cleaning purposes significantly increases the levels of airborne dust and therefore the risk of dust inhalation. A good alternative to a manual vacuum cleaner system with HEPA filter is a central vacuum system with centralized waste collection and treatment. Regular filter maintenance, HEPA filters, and a well-considered design are key to prevent any dust formation at the collection bin within this kind of a system. Depending on the size of the spillage, the use of a sorbent material may be considered for cleaning up puddles of liquids that may contain enzymes. The contaminated sorbent must then be carefully collected and placed into a sealed plastic bag to avoid further contamination. This plastic bag or container should be properly disposed of, for instance by incineration or through a waste treatment plant. Respiratory protective equipment should be used for all cleaning and spillage operations because the risk of exposure is always high. Whilst the area is being cleaned, it is also important to make sure that it is isolated to prevent the risk of exposure to people passing by and also to avoid spreading the spill any further into other areas of the production plant. In general, filtration systems in flour mills and industrial bakeries may be fairly sophisticated compared with those in smaller artisan bakeries. Nevertheless, the minimum standard of filtration required is still F8, formerly EU8, and after filtration, the extracted air should be discharged externally from the building so as to prevent dust formation within the building itself. Bag, sock, or cartridge type filtration systems are recommended. The exhaust should be positioned in such a way that the air cannot re-enter the building. Older industrial bakeries without ventilation units, or modern bakeries where the minimum ventilation requirements have not been met, should consider whether it is feasible to design and retrofit a simplified ventilation unit that does meet the minimum requirements. Where retrofitting of a filtration system is not possible, either a constant airflow or air circulation and air refreshment with a maximum airflow of 1 meter per second at ventilation openings is recommended. This is a high airflow to work in, and it is important that the turbulence intensity is kept as low as possible, preferably below 30%, in order to prevent an increase in dust formation. Turbulent zones are responsible for higher exposures to particles in the breathing zone, even if the operator is not performing dust-generating tasks. If no other options are available, opening doors or windows can help to prevent high peak exposures of airborne enzyme dust and aerosols, but this should only be considered as a last resort if no other measures are possible. When an optimized system of area ventilation is in place, then the opening of doors and windows should be avoided, as this will change the air circulation.
Okay, thank you, Sarah. Before we will continue with questions, I first would like to have a summary to summarize this session. Enzymes can be safely used, handled and processed by the bakery sector if the best practice guidance is implemented. They are valuable and extremely beneficial ingredients for the bakery sector, and I want to emphasize that they are safe for the user, for the consumer, and for the environment. Having said that, given the right conditions, they can be respiratory synthesizers for workers, in the same way as many other proteins that are already present in flour can be sensitizers. There is no evidence at the moment to suggest that enzymes are allergenic for consumers of bakery products. In short, we recommend that you assess the risk for dust formation for all the steps in your process where enzymes may be used. Limit the formation of dust as far as possible by transferring flour, enzyme preparations, and bakery mixes in a smart and gentle way. Use ventilation systems wherever possible and respiratory protection equipment wherever it is needed. Finally, don't forget to consider your waste streams as a risk area for possible dust formation. All the best practices we have described can also be found in the guidance document on which this webinar and the 3 other webinars are based. This guidance document can be accessed and downloaded via the AMFEP and FEDIMA websites. That brings us to the end of this webinar. It's of course not possible to cover every conceivable process and task in a short time. But hopefully what we have presented has provided you with useful information and has given you some food for thought. We also hope that this webinar, together with the others, will help you to assess your business and working processes and encourage you to implement the necessary measures to limit dust formation. In addition to the guidance document, other information may be found on the AMFEP and FEDIMA websites, as well on the other websites shown on this slide. And again, as mentioned earlier, this webinar is recorded and will also be published on the FEDIMA and AMFEP websites. If you have any questions, we have already received a number of them. We will try to answer them, but give us please a few minutes to collect them all and to make sure that we have the right answers.
So thank you very much, Sarah and Martin. As Martin said, we will now collect the question we received during the webinar. But please, if you have any more questions, feel free to send them to the Q&A participant in the participant list. So please wait for 1 or 2 minutes for us to collect now. So we are back now, and maybe Martin, you can start reading the question and trying to answer.
Yeah, there is a question that asks for spillage cleaning, if the operator is using protective equipment, can in that case a normal vacuum cleaner be used? I would strongly recommend not to do that, because the exhaust from the vacuum cleaner is having all the enzyme dust still there, spreading it through the environment. And maybe the operator at that moment is protected, but everybody else coming into that same environment will immediately run into the dust. So I would definitely not recommend that.
Next question.
Okay. The next question is, are the suggestions provided for enzyme dust control also effective for other allergens present in the products being used? I would say from a gluten, I'm guessing this is
It's flour.
It is flour. Yes, the preventative measures that we're recommending are for dust as a whole. So that would include flour dust. In terms of other allergens, I suppose that would depend on the particle sizes of the allergens concerned. So things like, I'm guessing we're talking about soya and possibly egg powders and milk powders and things like that. Yes. But yes, I think the general recommendations we are making would also apply to those other ingredients.
Yes. Then there is a question, or actually it's actually two questions which I would like to combine. And that is, should protective equipment always be worn at all times when working with enzymes? And the other question is actually, can you estimate how much dust formation can be reduced when working in the way we have just described? Well, the answer to the last question, how much can you reduce the dust formation, is, well, we can reduce a lot when you work in the way described, but not everything, very clearly. For that reason, the answer to the first question is, should protective equipment always be worn? Actually, the answer is yes.
So we still have time for a couple of questions, or maybe another one.
We have a question which asks, what enzymes does flour contain? Well, I think this can vary from country to country, but flour does contain naturally occurring enzymes. It contains alpha and beta amylases and serial amylases. But there are countries that regularly add enzymes to flour as it is being milled. That will vary from country to country, so I would recommend you check with your flour supplier to see if they are adding enzymes, and if they are, what they are adding. But yes, all flours do contain enzymes of one sort or another, because they are naturally occurring biocatalysts.
Yeah. Then there is a question if bakery powders can be put in paper bags instead of in polyethylene bags. Well, in principle, of course, that can be done, yes. However, paper bags would allow moisture from the outside air to go in, which may cause lump formation into the powder product. But for the second reason is that bakery powders may contain fat. And if you only have a paper bag, that would certainly be shown on the outside that fat is present. Normally, the paper bags that we use are covered with a polyethylene interliner. So that means it's a combination of paper and polyethylene. And there is also another question about packaging. Can we adapt packaging in such a way that we prevent spillage? For instance, can bags be equipped with adapted dosing systems? Well, I'm not a packaging expert. I would say technically yes, but I think it will also clearly lead to an increase of the price, of the cost of the packaging. And it is the fact that it's not yet available shows probably the answer that no, the packaging industry is not yet there. Then there are also two questions which are related to the dust concentration limit, and also can we verify or measure the concentrations of dust present. Well, there are certainly dust regulations available. They are different for, as you can imagine, for enzymes and for flour dust. Yes, we can measure both the enzyme concentrations in the air and the dust concentrations in the air, the flour dust concentrations in the air. Yeah, thank you. That's indeed the case. This will be more a topic of the next webinar. And you can certainly find answers on these questions also in the guidance document, which is available on the websites.
So we actually have addressed all the questions we have received during this webinar. So with this, I would like to conclude today's webinar. Thank you very much for your participation. Our next webinar will take place on the 26th of November, so next week. And as I said, you can still register via our both websites, AMFEP and FEDIMA. And finally, we would like to thank our partner for their support in promoting the webinar series on the safe handling of enzyme in the bakery sector. So thank you very much all for your participation, and have a nice day.